So moving on to the technical feasibility quadrant, we're now looking at our product or our service in terms of, can we make this? Can we actually do this technically? So first question here, would it technically be possible to design a product with the required functionality? So we're taking some of the information that we've gathered when we did our market analysis in terms of functions and benefits and the things that we need to include in our product and service, and then we need to now ask ourselves, well, can we actually design that? Can we create something that would deliver those features and benefits? And designing a product and then actually being able to produce that to scale to the numbers that you would need in order to make this a financially viable product are two different questions. So the second question there, can we mass produce it? Or can somebody else mass produce it, and can we outsource this to China? Or can we hire in some extra people and get a warehouse and set up a production line? Would the product or the manufacturing process require breakthrough technology, or is it something that's currently available? So are we trying to do something really new where we would have to actually create some new technology or some new process in order to make this product? Or is this a product which uses well-known technology? The more breakthrough technology, the more new processes that are required, whether that's new to your business or new completely, obviously the higher the risk. So the more difference that there is between the technology that your company and yourself are used to dealing with and the technology that you need to master in order to make this happen, the wider that gap, then obviously the more risk there is that technically this product or service may not get off the ground. So looking at the risks around technical feasibility, it's quite easy when you're in product development or service development to think, I've got to put in everything. I've got to make this all singing and all dancing. But that can lead to a risk of technical over complexity. So put in as much as you need to satisfy your customers' requirements and also give you a unique selling proposition, a differentiator in the market. But don't over engineer or over fill your product or service with things that you don't necessarily need. It also means perhaps that you've got some more stuff that you can put in version 2 and version 3, which you don't have to put in necessarily in version 1. A simpler product will typically be less prone to being fragile, to having problems, to breaking, because fewer moving parts mean that there's less to go wrong. So the risk of developing a technically fragile product, have you actually developed something which is going to fail later on? As I record this video, there's a lot of news in the press at the moment about Samsung and their latest phone, which has had a lot of problems with batteries and has been withdrawn from the market. So when you're developing your technical supply chain, it's not necessarily just you and your immediate people, but it's anybody who is contributing to the construction and to the product as a whole. Because if one of your suppliers' products causes a problem and that's part of your product, then it will be seen as your product that's the problem, rather than just the fact that it was a battery or that it was a component. And then what is the risk of the project being a technical failure? If you're as big as Samsung, you can maybe afford to write off $2.3 billion over your, from your profits. But most companies who invest in projects need them to be a success. So can you afford for this to be a failure? And if it was a failure, what would that do to your company? And that's something that then you look at from a strategic point of view in terms of weighing up the risk and the reward.